Okay, so get this. We're diving into AI, trying to do something pretty mind-blowing,
Oh.
creating mathematical conjectures.
Whoa, hold on. AI coming up with new math.
You heard that right.
That's a big one.
It really challenges how we think about machines. Math has always been this human thing.
Yeah, for sure. Needing all that creativity and intuition.
Totally. And now we're seeing AI like dipping its toes into that water.
Fascinating.
Absolutely. The paper we're looking at is First Neural Conjecturing Datasets and Experiments.
Okay.
And these researchers, Joseph Urban and Jan Jakubiv, they use this huge collection of like formalized math. It's called the Mizar Mathematical Library. It's like a giant digital encyclopedia of theorems, definitions, and proofs, all written in a way both humans and computers get it.
So like translating the language of math?
Exactly.
Wow, the sheer size of that must be.
It's massive, 78 megabytes of uncompressed text.
78. That's wild.
Yeah, to give you an idea of the scale, it's
Yeah.
like they gave the AI all of math and said, go learn from this and add to it.
Uh-huh. I like that. And what AI are we talking about here?
Probably one you've heard of, GPT-2.
Oh, yeah, GPT-2, the one that writes like a human.
That's the one. It's usually trained on like novels and articles.
Right, tons of data to predict the next word.
Exactly. But these researchers, they pointed it at the Mizar Mathematical Library.
Huh, I wouldn't have thought of that.
Me neither. It's super creative. They actually use different formats of the Mizar data.
Like what?
So raw text HTML and even these things called tokenized proofs.
Tokenized proofs?
Yeah, it's like breaking down the math arguments into smaller pieces.
Okay, so different ways of feeding the math to the AI.
Exactly. They wanted to see what helped GPT-2 understand this complex mathematical world.
Makes sense. So then what did they do?
They basically let GPT-2 loose on all this data.
Just let it go wild.
Pretty much.
Yeah.
It's called unconditioned sampling. Basically saying, hey, you've seen all this math, now show us what you can do.
No pressure or anything, haha.
Right. And this is where it gets really interesting.
Okay, I'm hooked.
The model starts generating text that looks like the formal language in the Mizar library.
No way. So it's writing math.
But it gets even better. It starts making what look like actual mathematical conjectures.
Hold on, so it's not just copying, it's actually trying to come up with new math ideas.
That's what it looks like. It's like it's trying to join the math conversation.
That's incredible. But how do they know if the AI is actually onto something?
Great question.
Yeah.
They didn't just take the AI's word for it. They used these things called automated theorem provers.
Theorem provers.
Yeah, think of them like robot mathematicians that double-check the AI's work.
Okay, so they're testing if the AI's ideas actually hold up.
Exactly. And what they found is a mix of results, which is what makes this research so exciting.
I can't wait to hear more. Some of what the AI came up with were valid conjectures.
Yep.
Logically sound, they worked. But, maybe not groundbreaking new stuff.
Right, so the AI is at least getting the basics of math.
Yeah, exactly. Like, it understands the rules of the game.
But then it went further right. Didn't some of the AI's conjectures actually turn out to be provable?
Yes, that's the really cool part.
So the AI is contributing to math knowledge.
Potentially, yes. If a conjecture can be proven, it's like the AI added something new.
Wow, that is wild. So not just mimicking, but actual new insights. But if some were provable, I'm guessing some weren't. What happened there?
Well, some were false, and some were already known by mathematicians.
Oh, okay.
It's early days for this research,
Sure, makes sense.
But even the less successful attempts were helpful.
How so?
They gave clues about the AI's thinking, where it went wrong.
Like watching a student learn.
Yeah, exactly. You learn from mistakes, too.
That makes sense. It's not just the right answer, but how the AI got there. Did the researchers share any specific examples of the conjectures?
Oh, yeah, they did. One that stuck with me was almost identical to a real theorem in the Mizar library.
No way. So the AI rediscovered something already known.
Yeah, same structure, same language.
Oh.
It's like it aced a math test.
That is pretty impressive. What about when the AI tried to go beyond what it knew?
There was this one that took an existing theorem about finite groups,
Right.
and it seemed to generalize it. Got rid of the finite part.
So like saying, hey, this rule works even broader than you thought?
Yeah, exactly. Bold move.
It is. And that kind of thinking is what pushes math forward, right?
For sure. Sometimes a new perspective is all it takes.
So did the AI always get it right when it tried these big leaps?
Oh, no. Sometimes the conjectures were false.
Right.
But even those were interesting. They show the limits of how the AI is working now.
I'm seeing a theme here. Even the failures are useful.
Absolutely. Mistakes are part of learning for everyone. AI, too.
You mentioned some of the most interesting conjectures were the hardest to prove. Why is that?
It means the AI might be onto something truly new, not just what it learned.
Okay, that's mind-blowing. Going beyond human knowledge.
Yeah, and those hard-to-prove ones, those are the exciting ones.
Do you have any examples of those really challenging ones?
Remember those automated theorem provers checking the AI's work?
Yeah.
Well, once the AI proposed a set of premises for a theorem.
Like the building blocks of a proof.
Right. And some of those premises were totally new, never seen before in the Mizar library.
Wow. So suggesting new ways to prove things, too.
Exactly. And get this, 5 of them were actually used in a new proof.
So the AI guided the theorem prover.
Yeah, like a detective pointing out clues.
That's a great analogy.
Yeah.
Then there was this other one about groups. It took a theorem about finite groups
Right.
and basically said, I think this applies to all groups, even infinite ones.
Big generalization.
It is. Has it been proven?
Not yet. But the fact the AI came up with it is remarkable, thinking beyond what it learned.
So showing us new ways to look at familiar math.
Yeah, for sure. We've seen it rediscover things, generalize, and even propose totally new ideas. What does it all mean for the future of math? Could AI actually be a partner to mathematicians?
That's the big question, isn't it?
It is, and the answer is potentially yes.
That's huge.
Yeah.
It's exciting and kind of scary at the same time.
Yeah.
If AI can help us with math breakthroughs, think of physics, engineering, economics.
Exactly. More efficient energy sources, life-saving medications.
Right. It's crazy to think about.
And you know what's really wild? It could help us make even better AI.
Whoa, hold on. AI helping to build better AI.
It's like this innovation loop feeding back into itself.
That is mind-blowing. Okay, but before we get too ahead of ourselves,
Yeah.
what are some of the challenges we need to think about?
One big one is understanding how the AI gets to its conjectures.
Yeah.
We don't just want to take its word for it.
Right. We got to be able to check its work, make sure it's not just playing a pattern matching game.
Exactly. It has to be actual math, not just fancy tricks.
Yeah.
And another thing,
Yeah.
AI models like GPT-2 are only as good as the data they learn from.
So if the data's biased or incomplete,
The AI's output will be too.
that makes sense.
Yeah.
So it's not like AI is taking over math.
Yeah.
We still need mathematicians.
Absolutely. To
Mm.
guide the process, check the AI's work, make sure it's all legit.
AI is a powerful tool, but humans are still in control.
Couldn't have said it better myself. So is there one last example from the AI that you found really interesting?
Oh, definitely. There was one that really stood out. And remember how we said the harder to prove, the more exciting?
Mhm.
This one was a real head-scratcher. It was about this property called being homeomorphic.
Oh, yeah. That one's a bit tricky to explain.
Can you try? I'll admit it went over my head.
Okay, so imagine a donut and a coffee cup.
Okay.
They seem different, but mathematically you can transform one into the other without cutting or gluing.
Really?
Yeah, that's what being homeomorphic means.
So like changing shape, but keeping the same essence.
Exactly.
Okay, I kind of get it now. So what did the AI do with that?
The existing idea was that this property worked for shapes that weren't empty, like they had something inside them.
Right.
But the AI said, what if this works for all shapes, even empty ones?
Wow. So a more general, even more powerful version of the idea.
Yeah, and they're still looking into whether it's true. But it shows the AI can refine our understanding of math, not just create new stuff.
So it's making us rethink things we thought we knew.
Exactly. Looking at it with fresh eyes.
It's like math isn't just rigid rules. There's still room for creativity, and maybe AI can help us with that.
I think so too. This research isn't just about AI doing math, it's about expanding what's possible.
For both AI and us.
Absolutely.
So to wrap it all up, we're not handing math over to AI just yet. But this research shows a future where humans and machines work together.
It's a future full of possibilities, and that's what makes it so exciting.
It really is. It makes you wonder what other human skills AI can learn. What other fields could it change? The possibilities are endless. Thanks for taking this deep dive with us. We hope it sparked your curiosity and left you thinking about the future of AI and math.